Python. And after that, we'll be doing chapter 3, chapter 4, the analyzing, visualizing data. I really hope we can get to machine learning, but covering so much information in a span of 2 hours, 2 hours and a half, depends how long it takes, is going to be a lot for everyone. So I made sure that when I created this notebook, that you guys have enough information about everything that is there. So if I'm not able to get to it through this presentation, you can actually go on your own and see everything that is written, all the details, everything is super well maintained, so no worries about that. So let's begin. Uh, so first, if you're using this, if you're following with me with the downloaded notebook that we sent yesterday and you downloaded everything and you want to execute the commands while I execute the commands, it's pretty simple. So you have different cells. Those are usually called the text cells. If by accident you double click on them, don't worry, just press Shift Enter on your either on your Windows or Mac. I don't presume we have any Linux users in this group. And if you want to, this is going to be a text cell, and this is going to be the code cell, which if you want to execute it, simply just press Shift Enter. You can also press Control Enter if you wish, but Control Enter, what it does is that it keeps you in the same cell while the Shift Enter moves you to the next cell. So let's start with our first, pretty much the first program that everyone learns when they start coding is print hello world. So the way it works in Python, to print a statement, simply write print and insert the desired sentence. So if you wish to print a statement, like in our case, hello world, just put it quotation marks and press shift and enter and you will execute it. Let's move a little bit more. So the way we're going to be doing this workshop is that we're going to be building on stuff we learned before. So it's going to be a little house we're going to build at the end of the day. So let's go for variables and simple data type. You can also print out statement as a variable. In that case, statement is my variable is equal to hello world, which is another statement, and we just print it. It's a simple print statement. Your statement, your variable can be anything you desire as long as it fits to the Python syntax code, which we'll be covering later. No worries about that. You can also modify your value, your variable if you wish. You can add any value you want to it. Like for example, here we had statement, which was hello world, and now we have a statement, hello world and welcome to the tutorial, print statement, and now we have hello world and welcome to the tutorial. All right, so let's continue. I'll be giving you also like little tricks to do when you write your personal code, so it becomes very easy for you to read it later, or for other people if you ever willing to share the code. So variables name contain only letters, numbers, and underscores. They can start with a letter or an underscore, but not with a number. For instance, you can call a variable statement one, statement under dash one, but not one under dash statement. Spaces are not allowed in variable names, but underscores can be used to separate words in variable names. For example, greeting statements works, but greetings empty space statement will cause errors. So avoid using Python keywords and functions names as variable names. We will learn them a little bit later. For example, print. Don't name a variable print. You're gonna have a really bad time with that. So do not use words that Python has reserved for particular programming purposes, such as the word print. Yeah. Variable names should be short but descriptive. For example, name is better than n, student underscore name is better than s underscore n, and name length is better than length of the person's name. So yeah, let's try to keep it not too complex, but not too simple in terms of defining your variables. And also, one of the errors that a lot of people, me including, doing is be careful when you're using the lowercase letter I and the upper letter O, because sometimes they could be confused with numbers 1 and 0. In Jupyter, it's displayed differently, but if you use other environments like Spider, it gets really confusing. So avoid doing that too. So let's continue. Next, I'll explain, because you're gonna get errors. Everyone gets errors, it's normal, and I'll explain to you how to read those errors, how to understand them. We just tried to reproduce the same code we did before. Statement is equal to hello world and welcome to the tutorial. And in that case, I asked to print statement, but I misspelled it. So it happens. Sometimes you misspell your variables and you get an error. So right now, this is a very simple error paragraph that you get, you always look at the error that points here. It points you where the issue is, and then you look at the name error. Like in that case, name statement is not defined, which means that there's no such variable in the memory that is statement in that case. So you just have to change it. Here we go, and now it's all good. Yep, so let's go for next step, strings. Because most programs define and gather some sort of data and then do something useful with it, it helps to classify different types of data. The first data type we will look at is the strings. Strings are quite simple at first glance, but you can use them in many different ways. A string is a series of characters. Anything inside quotes is considered a string in Python, and you can use single or double quotes around your strings like this. So this is a string, this is also a string. You can also add quotas in the string. So if I execute this command, in this case, it will only show me the last line because that's how Python works. It will only show the results of the last line. But if I insert print in front of all those string statements, then in that case, I will pretty much print all of them. So also little tricks that we're going to be doing too with strings. You can also add changes to your string by executing following commands. In this case, my variable is Artem Pilzak, print name, it prints my name. Then I want to print it with as a title, so it prints Artem Pilzak with A and P capitalized. Then I want to print it all in uppercase, so it goes as Artem Pilzak. I want to print it all in lowercase, and it goes that way. So those are very useful things to learn. So the lower method is particularly useful for storing data, especially, for example, for anyone who does psychology studies and wants to to put have a GUI, a graphic user interface where people will put their names in your program, but usually when people write their names, they always capitalize their first and last name. And then when you're going to be analyzing the data, you can just simply put lower for everyone and it will go down. The reason to do so is because the Python is very, very picky on how you define your values. So in this case, if you're trying to build it, and you just write one letter that's capitalized, you might get errors. So you'll see later. I'll give you really good examples for that. So um, let's go with using variables and strings. In some situations, you'll want to use variables value inside a string. For example, you might want two variables to represent a first name and a last name respectively, and then want to combine those values to display someone's full name. So now we're gonna have three variables, and two variables will create one variable. So in this case, we have first name, Artem, last name, Pilzak, and then full name is the combination of the first and last of the first and the second variable here. The F stands for format because Python formats the string by replacing the name of any variable in braces with its values. So to simply to insert the variable's value into a string, place the letter F before the opening. In this case, we're going to put my first and last name in braces, and then we're going to execute it, and we're going to get my name here. Adding white space to strings with tabs or new lines. I'm not going to go too much in details about it. You can, it's just pretty obvious. You just have to insert that right slash t, right slash n, right slash t if you want to indent, right slash n if you want to go to the next line, and if you want to combine both indent and next, just add those together. But it's not something that has to be covered. You will apply it when you need it. So stripping white space. White space in general is the empty space here. So if I have a string that has empty white space here, I want to remove it. I just simply do rstrip and it removes it. What if I want to strip the white space permanently? Then you just you create it as a new variable in that case. Because if you do not create a new variable, it will not be stored in memory. So yeah, use the following commands to modify the white space. To remove white space in the right side, rstrip, the left side, lstrip, both sides, strip. So sometimes you'll have space on the left side, sometimes you have space on the right side, sometimes you'll have space on both sides, and you'll be using the following commands. So yeah, Python is the easier language to learn, no brackets, no main, but remember, you'll get errors for writing an extra space, and that's completely normal. That's pretty much where everyone finds their error. Let's continue. Numbers. Numbers are used quite often in programming to keep score in games, represent data in visualization, store information in web applications, and so on. Python treats number in several different ways depending on how they're being used. So let's first look at how Python manages integers because they're simplest to work with. So integers you can add, subtract, multiply, divide integers, whatever you want to do. If you want to do exponents, just use double star. That's it. Uh, then you can also support Python also supports the order of operations, so you can use multiple operations in one expression, or you can also add parentheses to modify the order of operations, like in this case, 2 plus 2 times 10, well, 2 times 10 plus 2, and then in brackets, so it follows it naturally. Then we're going for floats. So the difference between integers and floats is the decimal point. Floats have decimal values, integers do not have decimal values. So Python calls any number with a decimal point a float. So 1.2 plus 1.5 will give you 2.7 and so on. But remember that when you do, you can when you divide any two numbers, even if they're integers, that result will always be displayed as a float with a decimal point, just like it is displayed here. And yeah, compared to C++, you can you cannot compare a float and integers. In Python, a variable is a variable. Do whatever you want with it. Underscoring numbers. When you're writing long numbers, you can group digits using underscores to make large numbers more readable. In this case, the universe age is 14 billion years. Well, let's print the universe age and it prints it that way. It's not going to print it as if with the underscore, but for you, it's much easier to write it that way unless when you're working with big numbers. You can also do multiple assignment. You can assign values to more than one variable using just a single line. And like in this case, x, y, z is equal to 1, which is x, y is equal to 2, and 3 is equal to z. You can put the whole alphabet if you wish to, and put all the numbers you wish, and you will always get the same result if you do it, if they're appropriate to each other. Constants. So very constant, it's a variable whose value stays same throughout the life of a program. Uh, for example, if, like I say, if you're going to be doing any data analysis and you have a constant by which you're going to want to multiply your results, well, it's always going to be the same. Whenever you're going to be writing a constant in Python, Python programmers always use capital letters that indicate that it's a constant. That's a way for other programmers to read it and be like, okay, this is a constant. We do not touch it. We do not play with it. Yeah, so that was a briefly review of constants. And now before we finish chapter one, which was a pretty short one introduction, I want to quickly go over the pretty much the philosophy of Python and how it works. And pretty much any programming languages will rely on the same principles. So in this case, you just import this, and it gives you the Zen of Python by Tim Peters. Beautiful, beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently. Unless explicitly silenced in the face of ambiguity, refuse the temptation to guess. There should be one and preferably only one obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now it's better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. So pretty much to sum it up, when you're going to be writing any Python code, what you want to try to do is to make it simple, to make it very easily to read, to define, to show people what are you doing, and that's pretty much it. And we'll be going through a few examples where we're going to be taking something that was complicated and making much simpler to read and to look at. So no worries about that. But if you abide by these rules, you'll be very well off in Python world. All right. So let's get to chapter two, Python data structures. List. So a list is a collection of items in a particular order. You can make a list that includes the letters of the alphabet, the digits from 0 to 9, or the names of all the people in your family, whatever you can imagine, you can put in a list. In Python, square brackets indicate a list, and individual elements in the list are separated by commas. So let's have a pretty simple list here. Uh, we're going to have a variable motorcycles, and it's going to be equal to the list. So it's going to be cruiser, sport, touring, adventure. Those are the items in our list. We have 4 items. So when we want to print the motorcycles, well, we get the cruiser, sport, touring, adventure. Now, we're going to get to a little bit uh, complicated first, but then we're going to understand. Then we're going to just get it. So no worries about it. Accessing elements in a list. So lists are ordered collections, so you can access any element in a list by telling Python the position or index of the item desired. To access an element in a list, write the name of the list followed by the index of the item enclosed in square brackets. And remember that index position starts at 0, not at 1. So in this case, cruiser is, in a motorcycle list, cruiser is 0, sport is 1, touring is 2, adventure is 3. It's not 1, 2, 3, 4. It's 0, 1, 2, 3. That's how it works. So when I want to print motorcycles at index 0, so I insert square brackets 0 and I print it, I get cruiser. And then what we learned from previously, if you want to add a title to it, just add dot title and you get C capitalized, cruiser capitalized. If it's for sure not going to be working in the future with the list are have 4 items, you might be working with lists that have 1,500 lists. Some lists will be generated randomly. So if you ever want to access the last element in the list, just simply put -1 in the brackets and you'll get the last the last item in your list. In our case, it's the adventure, and here it is. Now, let's say you want to modify elements in the list. So my first list is motorcycles, brands, Honda, Kawasaki, Suzuki, right? Then we print motorcycles. We get our first list, Honda, Kawasaki, Suzuki. But then I want to be changing Honda for a Ducati. So the way we're going to do it, our we're going to be taking the value, the variable motorcycle. We want to change the first item in this list. So we're going to be putting 0, which is Honda. So Honda is motorcycles bracket 0 is equal to Ducati. Then we press Shift Enter and we get Ducati, Kawasaki, Suzuki. So Honda is completely eliminated. What if you want to add elements to a list? Simply just use dot append in the parentheses, add the variable you want to include. So in this case, we're going to be reusing the same list, our list motorcycles that is here. We're going to do dot append BMW and print motorcycles. So when we print it out, now we have a 4 item list. The BMW is added here. Well, it wasn't added. Well, it didn't exist here. Let's say you start with an empty list. Okay, that's easy. You just you name your list. In this case, we're gonna have a list called cars. We're gonna write cars equal to, and then we're just gonna put 2 empty brackets, nothing in it. And then slowly we're gonna be appending stuff to it. So we're gonna add first thing, Mazda. We're gonna add the second thing, Ford. Third, we're gonna append Lexus, and then we're gonna print it. We're gonna get Mazda, Ford, Lexus. What what if you want to remove an item from a list? You can just use the del, which stands for delete. So you're gonna be, I want to remove a second item in my list. In this case, if you remember, it's 0, 1, 2. So Mazda will be 0, Ford will be 1, and Lexus will be 2. So we want to delete the the second, well, third item, which is indexes as second in our list. So when we delete it, here it's gone. Lexus is gone. All right, let's continue for removing an item using the pop method. So the point, sometimes you'll want to use the value of an item after you remove it from a list. For example, in a web application, you might want to remove it, want to remove a user from a list of active members, and then add that user to a list of inactive members. The pop method removes the last item in the list, but lets you work with that item after removing it. So in this case, we're going to reuse the same list we had before, which was the motorcycles. When we print it, we get Ducati, Kawasaki, Suzuki, BMW. Then I want to remove the last component from a list and add it to another variable. So for example, in this case, we created a new variable called popped motorcycle is equal to motorcycle dot pop empty sorry parentheses, print motorcycles and print pop motorcycles. So after we executed the pop command, well, we don't have the BMW anymore here. It's associated now with a new variable that is not a list. Pop motorcycle is not a list. Now, uh, removing item by value. So if, for example, I look in my list again, we're gonna execute the motorcycle list, which is cruiser, sport, touring, adventure, and I want to remove touring from the list. So first we're going to print motorcycles to see what's in our list. Right now we know, but before you're not always going to be writing your list each time you want to change something in your list. Your list will always stay in the memory. You can just print it and see. And then you do motorcycles dot remove the command remove, and between parentheses you're going to put touring in quotation marks because it's in quotation marks here, and you're going to print it out and you're going to see that it's gone now. So now you're with 3 items in your list. All right, so now we're going to go for organizing a list. So if you want to sort a list permanently with the sort method, so back to the same list we used before. And when you execute the command sort, for example, for if you have strings in your list, as previously talked about, strings is just characters in quotation marks, it will sort it in an alphabetical order. So in this case, when we do motorcycles dot sort, we're gonna we did a change to our list, and now we're gonna print it out. So now we have it sort adventure, cruiser, sport, touring, as it's supposed to be in alphabetical order. Uh, what if you want to find the length of a list? Yeah, that's simple. Just use the command length, and between parentheses, you want to see which list you want to include here. So, for example, length motorcycles. Previously, we had cars. So let's say if we insert cars, so we have four, and yep. So that's pretty much it for the list for now, because we'll be moving for loops, which in the beginning seems a little bit complicated, but you will it will get to you really quick. So looping through an entire list, you will often want to run through all entries in the list, performing the same tasks with each item. When you want to do the same action with every item in a list, you can use the Python's for loop. So bringing back the list of motorcycles, we have four here. Now let's use the for loop. So I'm gonna have a new variable here. It's not a permanent variable, it's a temporary variable for motorcycle in motorcycles list. So I'm gonna be taking every, I'm gonna be assessing every single value in the list in like order. So I'll be going first. So for motorcycles, for motorcycle in motorcycles. So this will be my new variable. You can also code whatever you want. So we're going to be going for motorcycles and motorcycles, print motorcycles. So first motorcycle, cruiser, it goes for the for loop. We go in the list, we access the first variable. Then this first variable goes through what we want to be executing the for loops. In this case, we want to print it out. So here it prints out first. Then it goes for the second, which is sport. So the motorcycle now variable is sport. It accesses the second item in the values. Then it prints it out here, and then so on and so on. So we'll be in for loop, you're accessing each variable at a time. And it's very, very useful when you're working, especially with big lists, and you want to be doing changes or just looking at each item separately. For loops will be your go-to. So Let's make it even a little bit more complicated, doing more work within a for loop. So you can do just about anything with each item in a for loop. Let's print more information with the new value. So we're going back to the list we had before. Now we're going to have the same for loop, but now we're going to be using what we learned a little bit before. We're going to insert the F format before our quotation marks. We're going to have the new temporary variable we're creating in the for loop dot title. So we're going to be capitalizing the first letter of each variable associated with motorcycle, and we're going to execute it. So the way it does, the motorcycle, now the new temporary motorcycle will be cruiser because it's the first item in our list. It will go through here. It will be it's gonna have the first letter capitalized, and a sentence will be also a string will be added to it. So cruiser is a great type of bike. Then we'll go for the next. Sport is a great type of bike. Touring, so on, so on, so on. So this is pretty much how for loops work. You're accessing each item at a time. So let's make numerical lists. Python's using the range function. So Python's range function makes it easy to generate a series of number. So for value in range 1 to 5, print value. So we're going to be creating a list in the range of 1 to 5. And remember that in Python, your last numerical value will not be printed. So in this case, we're going to have 1, 2, 3, 4. If you want to add a 5, just simply add a 6, and you're going to have a 5 here. So you're going to be printing every single value in the range from 1 to 6. Now, using range to make a list of numbers. So if you want to make a list of numbers, you can convert the results of range directly into a list using a list function. So we're going to create a new list called numbers, and it's going to be equal to a list of numbers ranging from 1 to 6, not including 6. So when we're going to be printing out the list, it's going to create 1, 2, 3, 4, 5. So this is how you create a list, and if you want to create a list with numbers. We can also use the range function to tell Python to skip numbers in a given range. If you pass a third argument to a range, in this case, this is a first, second, third argument, Python uses that value as a step size when generating numbers. For example, here's how to list the even numbers between 1 and 10. So we're going to create a new list. Our new list will be called even numbers. It's going to be equal to list. Inside the list, we want to create a range of numbers from 2 and 11, and we skip every, and we skip two, or we skip one number at a time. So we're going to have 2, but we won't have 3. We'll have 4, but we'll skip 5, 6, and so on. That's how it will create an even number. So the third argument will always be the step size you want to have when you generate a number. You can create almost any set of numbers you want using the range function. In this case, squares. We're going to be creating an empty list. We create an empty list to store squared variables. Oh, and by the way, I forgot to mention in the beginning that anything that has a hashtag and a sentence followed is just a comment that you can also add to your code. It does not do anything. It's just there for users to see what's happening. In this case, I'm explaining which line does everything, but it does not execute. It doesn't affect code anyhow. If I delete this sentence, I will still get the same results. It's just a comment. So, sorry. So we're going to create an empty list that we're going to call squares. So now we're going to have a value. It's going to be our temporary variable in range of 1 to 11. So we're going to have accessing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 separately, like one at a time. So what we're going to do is that, so we're going to have the first value is going to be 1. So our value is going to be 1. We're gonna square it, and that's going to be our squared value, and then we're gonna append that value to our list. If you remember before, append is to add new stuff to your list, and we're going to be doing that for every single number from 1 to 11, but in this case 11 doesn't count. So when we print it, we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So this is how we started with an empty list. We implemented a for loop, and in the for loop, we asked to square every single value in the range from 1 and 11, and we then appended to our list, and we then printed out the list. So if you have a choice to write your code more simply and obtain the same result, go for simplicity. As previously mentioned, simplicity is your go key. So in this case, it's the same idea, but instead of implementing square equal value 2, I just do squares dot append and the value to the power of 2. That's it. And it gives you exactly the same results. Simple statistics of a list numbers. So if you wanna see what's the minimum numerical value in your list, if you want to see your maximum numerical value in your list, and if you want to see the sum of your list. So it's gonna, in this case, it's 1, it's gonna be our minimum, so it's our minimum. 100 is gonna be our maximum, and the total sum of our list will be 385. So now we're gonna go to the working with part of a list, slicing a list, and that's it's. I'm not gonna go too much in details because later on I won't be working with it that much. But the point of slicing a list is that I want to only retain a certain part of the list, and the rest I don't care about. So the way you do it in this case, we're gonna have players. For example, we have a list of players. There's Charles, Martina, Michael, Florence, Ellie, and we're going to print players from 0 to 3. So 0, 1, 2. The third won't count. The last one never counts. Same thing as here. Here we want to print from index 1 to 4. So Martina, Michael, Florence, Li won't be included. If you want to print from 0 till a certain number, you don't have to put 0. You can just leave it empty, 2 dots, and insert where you want it to stop. So in this case, we wanted to stop at Florence. And you can see that in this case, the last it includes the last one as well because 0, 1, 2, 3 in this case it includes, but that's one of the index things that Python works with, and it's can't really explain why it's like that, but when it was programmed, it's this way. So sometimes you will find yourself finding small things that you don't understand, but it will come to you. So here we're gonna go to automatically start a third variable and so on, and automatically prints the last 3 players, so the -3. As like I mentioned before, the -1 you want to see the last item in your list. Well, -3 you're going to print out the last three person in your list. So let's loop through a slice. You can use a slice in for loop if you want to loop through a subset of elements in the list. So we're going to have the same players: Charles, Martina, Michael, Florence, and Li. And then we're going to print here are the first 3 players on my team. Uh, So for player in players until slice 3, so we're gonna stop at Michael in this case. So we're gonna go each player at a time, Charles, Martina, Michael, and then we're gonna print it out and we're gonna include the title. So it means that it's not gonna include Florence or Ally in this case because we only ask it to index at 3. And that's what it does. Charles, Martina, Michael. Copying a list. Often you'll want to start with an existing list and make an entirely new list based on the first one. To copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index. So in this case, let's say my favorite foods is pizza, falafel, carrot cake, whatever. And I'm going to create a new variable, friend's food. So it's going to be equal to my list, my food. So my friend's food will be the same, pizza, falafel, carrot cake. So then I'm going to print out uh, our lists. And then I want to add a new item to separate but identical list. So for example, to my food, I want to add cannoli, and to my friend's food, I'm going to add ice cream, and I'm going to print it out. So so as you can see, we had the same list, but then at the end we added new stuff, ice cream. The reason that you have to use you might be saying why I just don't write friend's food is equal to my foods. Well, in this case, appending new items to each separate list will not work. So in this example, I have friends foods equal my foods. I didn't use the index. And then when I try to reproduce the same code, you're going to see that here it's when I add canola and ice cream, it adds it to both lists because both lists are stored in the same memory and will be used the same way. So it's just an identical copy of the list, but any modification you will do to it, it will retain to the other list as well. While in this case, including brackets and two brackets in the index, it will be completely opposite. All right, so let's go for tuples. I'm not going to be covering tuples that much because honestly, I don't know a lot of people who use tuples in general in Python, unless you're a lot of in software developing or web developing. But in this case, a tuple is a list. A tuple is pretty much the same as a list, but there's a big difference. So lists work well for storing collections of items that can change throughout the life of a program. The ability to modify a list is particularly important when you're working with a list of users on a website. However, sometimes you'll want to create a list of items that cannot change. So, tuples allow you to do just that. Python refers to values that cannot change as immutable, and immutable list is called a tuple. So, pretty much a tuple is like a list with items that you cannot change. They are there forever, and there's nothing you can do to change them. There are a few things I will show you later, but in general, there's nothing you can do. So a tuple looks just like a list except you use parentheses instead of a square brackets. Once you define a tuple, you can access individual elements by using each item index, just as we learned in the list. And in here, we're going to use an example. If we have a rectangle that should always be a certain size, we can use that its size does not change by putting dimensions into a tuple. So dimensions is equal, parentheses, 250. Then we print out the the first and the second index, so 0 and 1, 250. But let's see what happens when we try to change a variable inside a tuple. So let's say I want to change the 200 to 250. Well, you can't do that. That's a tuple. So the tuple object does not support item assignment, which means that you cannot change. It is how it is, and you stick with it. Then same thing for looping through all values in a tuple for dimension and dimensions. So we're going to be going through each dimension 250 and we're going to be reprinting it out. So our temporary variable will be dimension. So it will go, so we'll have 200, print 200, here we go. Then print, the next one will be 50 and we'll print it. However, you can modify, although you cannot modify a tuple, you can assign a new value to a variable that represents a tuple. So if we wanted to change our dimensions, we could redefine the entire tuple. So if you want to do changes to your tuple, you you just have to change the whole tuple itself. You cannot change single things inside of it. So here we have dimensions 250, print original dimensions. Again, a for loop. We're going to be going through each dimensions and we're going to be printing it. Then we're going to assign, then we're going to create a new tuple and we're going to have the same name dimensions. So we're going to replace the old tuple. We're going to do the same modify dimensions. We're going to be doing a for loop for dimension and dimensions, and we're going to print it out. So it's going to be for 100 and 100. So that's pretty much for tuples. It's just a list that you cannot change items in. Let's go for if statements. So in this section, we'll learn how to write conditional tests, which allow you to check any condition of interest. And that's actually super useful, especially in psychology research. When you want to assign participants into different groups, you have to use the if or else, or we're going to cover more what else we can use. So let's start. So this is a simple example. So let's say I have my car's brand, Audi, Subaru, BMW, Toyota, and I'm going to implement a for loop. So I'm going to be looking at every single car brand in the list one at a time. So if the car, when the temporary variable looks at every variable and it's which is equal to BMW, I want to print it as an all in uppercase. If if it's anything else, I just want to print it with the first letter capitalized. And double Double equal signs, it's a conditional test where I want to make sure that my variable is equal to what I want it to be equal. If it's not, it's going to skip it. So in this case, we go car in cars, Audi. So in this case, the Audi goes through this. So it goes here. If car is equal to BMW, printed car upper. In this case, Audi is not equal to BMW, so we're gonna go for the else, print car title, and it's gonna be here, Audi, with just a capitalized letter. Same thing for Subaru. But then we get to BMW. So when we get to BMW, it meets the conditional test where if car is equal to BMW, it's going to print it all in uppercase. In this case, it prints it uppercase, and we continue and so on. So conditional test. At the heart of every if statement is an expression that can be evaluated as true or false, and it's called a conditional test. Python uses the values true and false to decide whether the code in an if statement should be executed. So as previously, excuse me. So I have a car, its name is BMW. Now let's verify, is my variable equal to BMW? Yes, it is. But then I say, is my car equal to Jeep? False, it's not, because my car is, when it was firstly defined, it was defined as a BMW. Now, as previously I mentioned how Python is super picky and how you capitalize and lowercase and all that, here it's a good example. Importance of using an appropriate case. Car, as previously mentioned, is equal to BMW. But now I say car is my car true? Is my car equal to BMW, but all in uppercase? In this case, it says false because it's all in uppercase. However, if I just simply put my variable and I add dot upper, as we learned before, we capitalize now the whole string here. Is it going to be equal to BMW capitalized? Yes, it will. So that's the importance of the lower and uppercase also. Uh, Checking for inequality. When you want to determine whether two values are not equal, you can combine an exclamation point and an equal sign. And the exclamation point represents not, as it does not, as it does in many programming languages. So, for example, you're building a pizza or whatever. Uh, you have a variable requested toppings is equal to the string mushrooms. If requested toppings, which is here, is going to be placed here, not equal to anchovies, print whole the anchovies. If in this case I say anchovies, in this case nothing will happen because I didn't add an else statement, but I can say else print continue with making whatever you were making. Now let's quickly go through numerical. We're going to come back to the if else statement a little bit later. Now I just want to go through numerical comparisons and mathematical comparisons because they'll be very useful for your if else statements. So double equal signs is to test condition. Same thing for exclamation and equal signs is not equal. So if I have an answer that is 17, if the answer is not equal to 42, print that is not correct answer. Please try again. But then if I have 42, it does nothing because I didn't add anything else, but usually you add. Combining other mathematical comparisons. So if I have h is equal to 19, you can have this is how you show it's smaller equal, greater equal. This is the signs you use. Checking multiple conditions. You can do it, but it's rare that I see people do that much, so I'm not gonna go over to it. If you want to check if your variables fit in a certain way you want it to fit, use and. So they need to meet both criteria. In this case, greater or equal to 21. And if you wanted them to just to meet one condition, then you just implement or. Then checking whatever a value is in a list. So requested toppings in a pizza, for example, is mushrooms, onions, and pineapple. Then I say mushrooms in requested toppings, true. But then I say pepperoni in requested toppings, false. It's not there because it's not in my list, so it's going to display as false. Then checking whether a value is not in a list. Other times it is important to know if a value does not appear in the list. You can use the keyword not in this. You can use the keyword not. in this situation. For example, I have a program where I have banned users. The list consists of Andrew, Caroline, and David, and then I have a user, Marie. And if my user not in banned user, then print format user that we had here, titles, because I wanted the first letter to be capitalized. You can post a response if you wish. And then I implement another one, user dash one, that's another variable, and we call that variable string Andrew. And if user one not in banned users, then we do the same thing. In this case, Andrew is in the list, so nothing happens, but Mary is not in the list, so she can go on with what she wanted. We can go on with the program that we have for her. Gonna go quickly over Boolean expressions. So true or false, that's Boolean values. It's just something you need to know in terms of definitions. So Boolean expression is just another name for a conditional test. Boolean values either true or false, just like the value of a conditional expression after it has been evaluated. Boolean values are often used to keep track of certain conditions, such as whether a game is running or whether a user can edit certain content in a website. So like game active is true, can edit is false, but don't worry about it too much. We're not going to be using it a lot, especially in data analysis that much. So coming back to if-else statements. So if conditional tests meet our criteria, do something. If it doesn't, do something else. In this case, I want to create a small program, for example, like voting age. My age is equal to 18. If age is greater or equal to 18, then you can print you're old enough to vote and have you registered for the vote yet. Since our age is 18, toss it fits the conditional test and we can continue with what was assigned to do. Now, let's say I want to have, let's say I have someone who is 17 and I want to implement an else statement. So if age is greater or equal to 18, same conditions, else means that if he's anything but lower than 18, then you have to display story you cannot vote yet. When you mention else, you don't need to write any condition for it. It's assumed. So if you're going to write condition, you're going to get an error in this case because else is any other situation except for if. So in this case, if age is greater than 18, so anything that is lower than 18 will be considered else, thus will be printed as sorry, you cannot vote. Now I'm going to make it even more complicated. I'm going to introduce the if, elif, else chain. So often you'll want to test more than two possible situations, and to evaluate this you can use Python's if, elif, else chain. It runs each conditional test in order until one passes. When a test passes, the code following that test is executed and Python skips the rest of the test. Many real-world situations involve more than two possible conditions. For example, consider an amusement park that charges different rates for different age groups. So I have admission for anyone under age 4 is free. Admission for anyone between the ages of 4 and 18 is $25. Admission for anyone age 18 or older is $40. So I have age equal to 12. If age is smaller than 4, your admission cost is 0. If age is smaller than 18, your admission cost is $25. And else if you don't fit in the two other category, then you're gonna have to pay $40. In this case, our age is 12. So we start. It starts with first condition. If age is more than 4, no, it's not. So we skip. We go to the next step. If age is smaller than 18, yes, it is. So my admission cost will be $25, and we completely skip the else. That's why it only prints your admission cost is $25. Now, like I said, remember simplicity is the key to successful programming. So in this case, age is equal to 12. If age is smaller than 4, then price is 0. If age is 18, price is 25. Else price is same thing, but it's much easier and faster to write it this way with when you use the format and you insert the variable in the format. But that's something you will catch up with time. It's completely normal in the beginning to write so many print sentences. You can insert as much elif keywords as possible as long as you can create conditions for those. So let's say same idea. I have admission park and I decided that anyone who is More than 65, well, your admission will be $25. So under 4 it's $0, under 18 it's $25. Between 18 and 65 it will be 64, it will be $40, and upper than 65 will be $25. So my age is 45. It does not fit. It's not smaller than 4, so we skip. It's not smaller than 18, we skip. It's not greater than greater or equal to 65, so we skip. So we get to the so we go to the else, which was the last condition. So the admission will be $40. But then I have someone who is 70, then same process, but he stops here because it's greater than 65, and that's what happens. Print you can fit this condition, print, the admission cost is $25. Same thing if I say you're a 2-year-old, well, it's going to be 0, so it's going to get 2h smaller than 4, and we're going to skip all the other condition tests because at this point it doesn't matter. Using if statements in a list. So requested toppings, right? I have a pizza. I have a list of items I want in my pizza: mushrooms, onions, pineapple. So for requested toppings in requested toppings, so I'm going to be going through one value at a time. That's why my list has a requested toppings, and then I have my temporary variable that is just requested topping because I'll be accessing one topic at a time. I'm going to add the requested topping. I'm going to format, quotation mark, adding, which is a string. Requested topping is the variable I want to insert. And then I'm going to say print, finish, maker, and pizza. But what if one item from the list is not available at the moment? So let's say you have a pizzeria and today you're out of onions and you receive an order where you have mushrooms, onions, and pineapples. So for requested topping, I'm going to be going through each topping at a time. So mushrooms, in this case, if mushrooms is equal to onions, print, sorry, we're out of requested toppings at the moment, else print adding mushrooms. In this case, mushrooms is not equal to onions, so we completely completely ignore this condition and go for the else statement. So we're going to go adding mushrooms, then we go through onions. Onions is equal to the onions, so we're going to have to print, sorry, we're out of onions at the moment, and we ignore this condition, and so on. And here how it looks when you implement an if item. And this is just an example. If you want to make it even more complicated, you can use multiple lists. You can use as much list as you want, if else, if statement as you can. It's really up to you. There is absolutely no limits. Just it's the only limit is in this case will be your imagination. So dictionaries. A dictionary in Python is a collection of key value pairs. Each key is dictionaries is going to be now another data type we're going to be looking at. So each key is connected to a value. You can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary, or a dictionary within a dictionary within a dictionary. Like I said, you can do whatever you want. In fact, you can use any object that you can create in Python as a value in a dictionary. So in Python, a dictionary is wrapped in braces with a series of key values pairs inside the braces. So like, for example, in this case, we have a game where you shoot aliens from the space, right? And if we have an alien, his color, this is going to be our key. The color, he's going to be key, and the value will be green. And then we're going to have a second key value pairs. In this case, it's going to be points, and the value associated with that will be 5. So when we're going to be printing out the key color, we're going to get green. Print alien points, which is our key, we're going to have only the value come out. So each time you're going to be calling a key, you will only get a value that is associated with that key. So yeah, when you provide a key, Python returns the value associated with that key. You can store as many key value pairs as you want in a dictionary. It doesn't matter. So let's say let's say we have new points is equal to the we want to now access stuff within our dictionary. So here we have a new variable, new points is equal to the alien dash 0 points. We're accessing the key points here. Alien color is now going to be the color associated with that key. It's going to be green. So when we're going to implement it, and we're going to add everything together, format, you just earned new points, this variable, for taking down a alien color, this variable, and all those variables will be associated with the values within that key. And yeah, you might think, why am I using braces in this case? Those braces have nothing to do with dictionaries. Those braces are only used when you're trying to format something. So those braces, those variables within the braces are not anyhow related to the dictionary. So it might cause a confusion, but just remember that they're inside the format. It's not anyhow related. So let's say I want to add a new key value pairs. Dictionaries are dynamic structures, and you can add new key value pairs to a dictionary at any time. For example, to add a new key value pair, you would give the name of the dictionary followed by the new key in square brackets along with the new value. Let's add two new pieces of information to the alien zero dictionary. So with the same alien we had before, print, that's what we get. Then let's say I want to add its x position, y position on the map. Well, then I'm going to create a new key, and the value associated will be that 0. I'm going to create a new key y position. The value associated will be 25. And then when I print now the new dictionary, I'm going to have x position and y position included in my dictionary. And this is how it looks like when you start with an empty dictionary. Same concept as a list, but in this case, you just have to mention the key you want to create with the value. A new key created with another value. You print it out, and here you go. You have a new dictionary. Let's say you want to modify values in a dictionary. To modify value in dictionary, give the name of the dictionary with the key in square brackets, and then the uh, the new value you want to associate with that key. So yeah, you're gonna have to learn how each bracket has its own purpose. Sometimes you'll be like, oh, but it's related to dictionary. No, it's not. Sometimes it's just how it is. Same thing for list and braces and parentheses, but you'll get used to those. It becomes natural after a while. So, for example, consider an alien that changes from green to yellow as the game progresses. Alien underscore 0 is going to be color, a key color with a value green. Print format, the alien is uh, the what we had the value associated with that key. In this case, we're gonna have the alien 0. We're gonna change the color, so we're gonna modify the key. Now it's gonna be yellow, and we're gonna redo the same thing we did here, and now it's gonna be yellow. So that's how you modify values in the dictionary. And this is just, I'm gonna skip this section. This is just if you wanna add even more, if you want to modify and even add more information with the if, elif, else statement, but due to timing, I'm not going to go over it, but feel free to go in your own time. But it's just how the speed of your alien can change the x increment that will be associated with the x position. Removing key value pairs, simple. You also use del as in the list, but you have to mention the key you want to remove. You don't need to mention the value, whatever. You never mention the value in when you're going to be coding it. You only mention the value when you want to change the value. But in this case, I want to remove the key points. I print out. That's it. No more points. Looping through a dictionary is pretty much the same concept as a list. You're going to be looping through each single key. So let's consider the following example. I have user. My username will be like A Pilzak. First name is going to be Artem. Last name will be Pilzak. You can access any single piece of information about the user under dash zero. But what if you wanted to see everything stored in this user's dictionary? To do so, you could loop through the dictionary using a for loop. So in this case, uh, comma value in user 0 dot items, you're gonna be, I'm sorry, I forgot to run this one. Here we go. That's if you want to display it this way. If you want to see really like, because now you're mentioning two temporary variables, so it's gonna go one. So the key username value Pilzak, so it will display that key first name value Artem second, and so on. Let's say now looping through all the keys in a dictionary. So now I have a list where I have favorite languages. So let's say Jen likes Python, Sarah likes C, Edward likes Ruby, and Phil likes Python. So for name in favorite languages, dot keys, print name title. So we're gonna go through uh, every single name is our key. So we're gonna go names, Jen, print Jen with a dot title, so uppercase first letter, and we're gonna do that for every single keys. You don't necessarily have to add dot keys. You can simply write for name in favorite languages without adding that. The reason that I added or I recommend adding it is because when you have a long code and you have dictionaries and lots of dictionary lists, and you're going to be writing a code and you want to implement a for loop, sometimes adding the dot keys helps you to remember that, oh yeah, that's right, this is a dictionary I'm going through, because unless you're going to be using for key value to display every single item, in this case we don't use two temporary variables, we're going to have only one, so we're only going to be displacing the first keys of the dictionary. So the dot keys just helps you to remember that you're working with a dictionary, but feel free to not use it, it's really up to you. So this is again using a dictionary with an if statement. I'm going to skip this section because like I said, we have time issues, and let's go for yeah, this is looping through a dictionary keys in particular order, looping through all values of the dictionary. So it should be uh, you can see those information on your own. I made sure to write enough information so you can understand it, because I was expecting to skip those sections because we have one more section to cover in this chapter. Is the functions, and I want to take a little bit of time with it. But yeah, feel free to go through this on your own, and if you ever have any questions about it, just email me or message me, and I'll be happy to answer. But overall, it's the same principle as a list. Nothing changes that much in it. Functions. Okay, so we're gonna go for our last section in this chapter is the functions. So in this section, we'll cover functions and how to use them. Functions are extremely important in any data analysis. If you wish to find a z-score, you need to implement a function. In general, functions are named blocks of code that are designed to do one specific job. When you want to perform a particular task that you define in a function, you call the function responsible for it. So for example, let's have a first simple function called greet users. So we start by defining the function. So def stands for definition of your function. So you're defining a function, followed by the name of the function you want to have. Parentheses. For the moment, we're going to leave them empty. Then we're going to use the indent, not indent, sorry, the 2 points. And then followed, we're going to put triple quotations. So the triple quotation in this case actually is a way to write what your function does. So it does not anyhow affect the function whatsoever. It just gives information about your function. And you want to implement that as much as possible because you're going to have 100, 150 functions, and you want to make sure that you know what they're doing and how they're doing, because sometimes just the name cannot give you all the information you need from it. So now we have a simple function called greet the user that we only ask to print hello. And then we call in the function greet user, and it gives us hello. Now, let's add more information to our function, passing information to a function. Modified slightly, the function greet users can not only tell the user hello, but also greet them by name. For the function to do this, you enter username in the parentheses of the function's definition. So in this case, our function, we define it as greet user. Now we're going to add a parameter here, username, and we're going to say what it does. Displays a simple greeting. Print format, hello, username, the variable that the person will put here, and dot title. So in this case, greet user, Artem. It's remember that it's always important in this case to actually add a username, because if you try to just call in the function, let's say, it it will be sorry, it will be an error because you're going to be missing one required position argument, the username. So you really have to abide by all the parameters inside the function if you want to execute it. But the moment that you've done building your function, you don't have to recreate it again. You just call it. So even for like you build to find the to do a t-test function, you build a big function, and then if you want to implement it in the future or anyhow you want, you can just call it in, put in your parameters, and it will execute. So quickly on the definitions of a function, so people can follow me through. The username here is going to be parameter, but when I write uh, a variable here, this is an argument for your function. So this argument will go through the function as a parameter. Positional arguments. So let's say I have a function that is called describe pet. So I'm gonna have a parameter animal type. I'm gonna have a parameter pet name and their first, second order. I'm gonna say what it does. So it displays information about a pet. So the first thing it's gonna do is that it's gonna say I have a animal type. So this parameter will go here dot. Then I'm gonna print my animal type's name is my pet name will go here. My animal type will go here. So I have a let's say I have a pet hamster Harry. Then I execute the function. I have a hamster. My hamster's name is Harry. And another one. I have a dog. My dog's name is Jasmine. So it's also important that the order matters in positional arguments as well, because if I implement the same function, but I do not put my arguments in the proper order, well, I'm going to have something that looks like that. This is, for now, it's something that it's quite obvious, but if you're running a big function and you have a lot of variables you have to implement, you might actually create errors. So respecting the positional arguments is really important in this case. Uh, So the keyword arguments, a keyword argument is a name value pair that you pass to a function. You directly associate the name and the value within the argument. So when you pass the argument to the function, there's no confusion. You won't end up with a hairy named hamster. So the definition, we have another function here. Definition, describe pet, our parameters, animal type, pet name. Same idea, what we had before. And then we're gonna be calling in the function. But if you want to make sure that if you want to change the orders of your argument, you can, but in that case you have to specify. So if I say describe pet animal type hamster, pet name Harry, and then I do the same thing but I reverse my arguments, but I still mention the keyword argument, in that case it will work for both. So you can do that, that's possible, but it makes it a little bit more complicated. Not complicated, but it takes a little bit too much work. Default values. So when writing a function, you can define a default value for each parameter. If an argument for a parameter is provided in the function call, Python uses argument value. And if not, it uses the parameter's default value. So when you define a default value for a parameter, you can exclude the corresponding argument you usually write in a function call. So in this case, same function we worked with, display information about a pet, but this time I have a default value, which is a dog. So when I'm going to be calling in my function, I do not need to mention animal animal type because there is a default value associated with it. So if I run it, I have a dog. My dog's name is Willie. If you want to change uh, if you want to change your default value, you simply call in the function again. But in that case, you're just going to specify a keyword argument. You're going to say animal type is equal to hamster, and in that case, when it's going to run through the function, the animal type will be changed for the animal type hamster for that case. But then if I call the function again, it's going to go back to the default value was before dog. So I have a dog. My dog's name is Jasmine. So that's pretty much how it is for functions. And for the last but not least, return values. We're going to go through this quickly because return values is something has to do with the function, but a way it's because a function does not always have to display its output directly. Instead, it can process some data and then return a value or set of values. The value the function returns is called a return value. The return statement takes a value from inside a function and sends it back to the line that called the function. So return values allow you to move much of your program's groundwork into functions, which can simplify the body of your program. So in this case, we have a function. Uh, First, get formatted name, return a full name neatly formatted. So I have a full name formatted, first name, last name, return full name. So I want to achieve this variable. I want to get this variable from my function. In that case, I have to create a new variable. I cannot, I have to create a new variable because it will be associated with this variable. So if I execute this command, so get formatted name, Jimi Hendrix. So first name is Jimmy, last name is Hendrix. So now Jimmy will go here, Hendrix will go here, return. So the full name now is formatted, Jimi Hendrix, return, full name, dot title, because I want to capitalize each first letter, and it prints out. Uh, you can also make argument optional. For example, if I want to include a middle name, sometimes not everyone has a middle name. So in that case, I will use a default value for my middle name. I'll put it between quotation marks, which just means that it's an empty string. So it can either be there or not be there. So if I run the same program, I have if else statements as we covered before. If the person who called in a function and added middle name. If the middle name is present, then it's going to go through this condition test where we'll insert the middle name where it's supposed to be. If there's no middle name, like else, then it's going to just insert first name and last name, and then return full name with a title. So in this case, I have a musician get formatted name John Lee Hooker. So since Lee is a middle name, in that case it fits and it goes through. Same thing for, and then in this case, I have Jimi Hendrix. There is no middle names, so we go for the else, and it prints out normal, so you don't get any errors. All right, and a function can return any kind of value needed to, including more complicated data structures like lists and dictionaries. For example, the following function takes in parts of a name and returns a dictionary representing a person. So function build person, first name, last name, return a dictionary of information about a person. So now I'm going to create a variable. I'm going to create a dictionary and I'm going to call it person. So my key will be first, the value will be the value will be first name, and my second key will be last. The second value will be last name, and then I want to return the person as a new variable. So in this case, I'm going to create a new variable called position, and I'm going to call in the function, and it's going to return to me the variable person as print in this case. So I have Jimmy that will be going as my first, so it's going to be first name, and then Hendrix will go as the last name. So then when it returns to me a nice dictionary. Then you can easily extend this function to accept optional values like a middle name, an age, an occupation, or any other information you desire to input. So let's say I have a same function, but now I have age. So if I want to add age in the dictionary, then I need to be sure that the person provides me with age. If the person who provides me, who calls in the function but doesn't have age, it's okay, because in this case I have none, which means that it's an optional parameter. You don't have to have it to execute the function. But if age is mentioned, then we're going to create a new key called age, and we're going to associate the value that person mentioned in the age here. So let's say I have a musician, a new value called musician. So I'm going to call in the function build person, Jimmy, first name, Hendrix, last name, age 27. And in this case, we're going to insert the person's first name. Jimmy is there. Hendrix is there. And if age is present, in this case, age is present, it's 27. So we're going to add a new key to the dictionary, which will be age. And the value that is associated with that key is 27. And we're going to return the person. So we get first Jimmy, last Hendrix, age 27. Then we're calling the function again, but we don't have the age for, let's say, for like Michael Jackson. In this case, it will just simply ignore that statement and will not execute it, and will only return the person, uh, dictionary originally mentioned here. So we're gonna be, well, time flies. Okay, so we're gonna be taking a little 15-minute break. We covered pretty much the basics of Python, and now you have idea how data and how everything looks like it. I didn't cover other stuff like class, while loops, and all that, but those things will come to you when you will actually have to apply them. So no worries about that. But everything what is mentioned and seen here, you will be able to continue with that when we're going to go for analyzing data and visualizing it. So I'll be taking a 15-minute break. And if you guys have any question or something, I'm here to answer them. No problem. So
Perfect, Artem. Thank you very much for the first section. So I guess for those that are there with us right now, um, we would be back around 11:20, 20-ish around there. And Artem's going to cover the next section, which is going to be analyzing data. And these are things that he laid a good foundation, and you'll see it'll be easier to understand for the next section. So if you have any questions, you can unmute yourself, you can ask, or if you would like, you can write them on the chat and we can read them to Artem. And we'll have a second period of questions in the end of the workshop.